Algebra 2, Section 5.8, we're looking at radical equations and inequalities. Let's take a look at the first example. So basically what we're doing here is we're going to be solving some problems or solving some equations with radicals in it. And there's a couple things. There's only 4 examples, so it's not a whole lot, but I do want you to pay attention to the techniques that we use. And the basic technique we're going to use is to isolate the radical when we can, and undo what's happening to the radical. So let's see what I'm talking about. So to solve this guy, I've got square root of x plus 1 plus 2 is equal to 4. To isolate this radical, I'm going to take everything away from the side of the equation with this radical on it. So that means this minus 2. This positive 2 needs to be gotten rid of. So I'm going to add a negative 2 to both sides. So I'm going to get square root of x plus 1 is now equal to a positive 2. So that's that. And now I'm going to undo what's happening to x plus 1, which is to square it. I'm taking the square root. The opposite of taking the square root is to square something. So squaring both sides is what I have here. When I do that, the square root being squared means that that value comes right out. I get x plus 1, and that's equal to 4. I'm going to finish off the problem by solving like I usually would. Isolate the x, subtract 1 from both sides. Boom, boom. When I do that, I get that x is equal to 3. Now, a habit that you want to develop when dealing with radicals is always, always, always take this problem, take your answer, go back to the original problem and plug it in. So I'm going to take my answer of 3 and see if it works. 3, square root of 3 plus 1 plus 2 equals 4. I hope that works. Let's see. Square root of 3 plus 1 is the square root of 4 plus 2 is equal to 4. 2, yes, plus 2 equals 4. So now I am confident to say that this is the answer. So I'm going to check that off, and I'm going to look at another problem. Let's go ahead and check out example 2. So here it is, example 2. What we have now is, before it was so awesome, we had like a radical here, and it was just alone. Now we've got 2 radicals, and this feels funky. But we have the mathematical skills to do it. It's going to require us isolating one radical, squaring it, both sides, and then isolating the other. This section is called extraneous roots because sometimes when you solve problems like this, you're going to get answers that don't work. And that's why I talked about in the last example that we should try our answers out in the original problem, even though we only had one there. So we were checking. We're going to do that here. So let's take a look at what's going on. So I start off with the square root of x minus 15 is equal to 3 minus the square root of x. I'm going to square both sides. I know you don't want to do it. I don't want to do it either, but we got to do it. So we square both sides. When I square this side, beautiful things happen. Pretty simple. X minus 15 comes out of the radical. Bling, very happy. However, on this side, man, oh man, this is really, let's come over here, 3 minus the square root of x times 3 minus the square root of x. From one of those other sections that we worked on, you know you got to rock a FOIL method or a distributive, extended distributive property. So we'll do this times that, and this times that. Then we'll do this times this, and this times that. Lots of work, but we can handle it. So we square both sides. This came free, and this one we got to do some work. Let's see what happens when we do that. So far, this is what we get when we FOIL it out. 3 times 3, 9. This times that minus 3 root x. This times that minus 3 root x. And this times that's a positive x because square root of x squared is a positive x. With that in mind, I'm going to join like terms together and put what this is, 9 minus 6 root x, right? Bring those two together, plus x. Now what you notice is we still got a radical, and that's not cute, but that's okay. We're going to handle our business. Now I'm going to isolate this radical by throwing everything onto the other side. So I get x minus 15, check this out, I'm going to subtract 9 on both sides, minus 9, right? I can write it like that. Maybe I shouldn't. Well, I'll just keep going. And then subtract the x on both sides, minus x is equal to negative 6 root x. I feel like this is confusing. Let me try again. Okay, so I'm going to do it again just because I felt like I was doing too much in one step. Let's go ahead and subtract x on both sides, right? When we do that, the x's go away. I'm left with a negative 15 is equal to 9 minus 6 square root x. And now let's get rid of the 9, because remember, my goal is to isolate this radical. So if I get rid of the 9, I subtract 9 on both sides, right? Or I add a negative 9 on both sides. I end up with, I'm going to just proceed over here, erasing this space, giving myself a little bit more space. So I end up with, arrow over here, I end up with a negative 15 and a negative 9, ends up giving me a negative 24 on the left side of that equation, and on the right side I'm left with negative 6 times the square root of x. I'm going to isolate this radical if I can, and to do that I'm going to divide both sides by negative 6. So notice your old school algebra skills come into play. And so now I've got the square root of x. Negative 24 divided by negative 6 is a positive 4. If 4 is equal to the square root of x, if I square both sides, you see where this is going, right? If I square both sides, x is now free and x is equal to 16. So now what I need to do is plug it in, plug it in. I cannot just say, oh, that's the answer and walk away when I'm dealing with radicals, because when you square stuff, you start making things that were untrue kind of true, and we can talk about that later. But if I put the 16 in here, let's see what happens. So I get the square root of 16 minus 15 is equal to 3 minus the square root of 16. So everything's looking pretty good. 16 minus 15 is 1. So this, I'm going to just go up. So the square root of 1 is 1. So I get 1 on this side. And then watch what happens here. Then I get 3 minus square root of 16 is 4. What? 1 does not equal 3 minus 4. In fact, 1 does not equal negative 1, which is what this was about to become, which is what this was saying in this problem, right? We've got 1 is equal to negative 1. That doesn't work. And so what we call this is an extraneous root. This is not a solution. And for us, there is no solution to this problem, right? Isn't it sad we did all that work and we got no solution? We always have to check, though. I know it seems weird, but sometimes weird stuff happens when you have radicals. Let's take a look at the next problem. So here we are. We've got cube root equation. And so we remember from a previous section that this 5, let me get it in a color you can see, 5n minus 1 to the 1/3 power is really just the third root of 5n minus 1, okay? So that's what this is the cube root because I'm raising it to the 1/3 power. Well, just like when we had the square roots, we needed to isolate the radical thing. Here, even though this is the third root or to the 1/3 power, we've got to isolate this thing here. And to do that, I'm going to come down and I'll write in black. I'll write in white on the black portion. I'll recopy this guy. So I'm going to look at it as that, like this, just rewriting it. And what we did last time is we isolated this radical term, which I'm going to call this a radical term. We isolated this radical term by moving everything away from it. We're going to do exactly the same thing here. And so 5n minus 1 to the 1/3 power. I'm going to add 2 to both sides. When I do that, that's equal to 2. And so I can also divide both sides by 3 to fully isolate that term. And then so now what I get is this thing to the 1/3 power, all right, stay with me, is equal to 2/3. How do I undo the 1/3 power? That's the thing I'm asking myself right now. How do I undo the 1/3 power? Well, to do that, I need to bring it to the 3rd power. In order to do that, I literally just say, all right, I'm going to raise you to the 3rd power. But what I do to one side of an equation, I've got to do to the other. So look at this. 1/3 to the 1/3 power. Remember, power to power means I multiply those powers, and therefore I get 5n minus 1 to the 1st power. That's it, which just means 5n minus 1. And therefore, I can deal with the other side. 2 to the 3rd power is 8, and then 3 to the 3rd power is 27. And I'm going to finish up this problem by doing the algebra that I know and love. I'm going to add 1 to both sides. And I end up with 5n, let me scooch this up a little bit, 5n is equal to 8 over 27 plus 1. I'm going to write my 1 as a 27 over 27 to make my life easier. So then I get 5n is equal to 27 plus 8 is going to give me a 35. It gives me 35 27ths. Still not done because now I got to divide by 5. If you don't remember this, please know that dividing by 5 is the same as multiplying by 1/5. And the reason why I'm choosing to do that is because I'm going to be able to simplify this a little bit better. So now I'm dividing both sides by 5 or multiplying by 1/5. Those guys cancel out. I am now left with n on the right side, and on the left side 5 goes into 35 7 times, and that's 1. So I'm left with 7 over 27 as my final answer. All right. Let's take a look at this. I think this is our last problem. Here we have a radical inequality. Just like with, oh, I wasn't a good teacher here. I guess I should plug this back in and check it because that's what we do. Let's do that. So notice I just put the 7 over 27 back in for n. I'm going to multiply through like I know I'm supposed to do. So I get this right here. And I'm going to change this 1 into 27 over 27. That's going to make me subtract a lot easier. So now I'm taking the third root, which is 1/3 power of 8 over 27, which I know to be 2 over 3, because the third root of 8 is 2 and the third root of 27 is 3. And when I do that, I'm multiplying 3 over 1 times that. These guys cancel. I end up with 2 minus 2 equals 0. I see my answers checked and I'm feeling good. Now let's go on to the next example. Just like last time, we want to isolate this radical. So we'll subtract 2 from both sides, and we'll end up with the square root of 4x minus 4 is less than or equal to 4. Now it's isolated. We're going to square both sides, which undoes the radical over here, and I get 4x minus 4 is less than or equal to 16. I'm now going to solve this like a regular algebra problem, isolating the x by first adding 4 to both sides, then further isolating the x by dividing both sides by 4. When I do that, I see that I get that x is equal to 5. As with all the other problems, I am going to go back and substitute it right back in there and check to make sure I know what's going on. So here's my check. I simply place the 5 right into the original equation, and then I start doing the thing that I'm supposed to do. I get my 2 plus 4 times 5 is 20. Minus 4, 20 minus 4 is 16. So now there's a 16 underneath the radical. This should be less than or equal to 6. 2 plus the square root of 16 is really 2 plus 4, which should be less than or equal to 6. And is 6 less than or equal to itself? Yes, it is. I feel confident about my answer. So this is just a smattering of the problems that you're going to see in the assignment. And the assignment is page 266, 13 through 39I. And we have one more section to go, which is section 5-9 and complex numbers. All right.